Okay, here we go. Is this, shall I make, just perhaps make it a wee bit bigger? If anybody's having trouble seeing, let me know. Okay, so we saw yesterday how to specify subroutines and functions with some dummy arguments, and we specify this attribute intent to describe whether the data is going to be read-only or whatever in the function or subroutine. I want to say a bit more about now what you can do when you have array dummy arguments, as there are one or two special things to watch out for. So one is imperfectly entitled to do something like this. We can pass in here a rank 1 array, and we explicitly also pass in the dummy argument list its extent, which is n max. So the array is explicitly declared in terms of being rank 1 and having size n max. It so happens here this is an in-out intent. That's okay. If you didn't, so the thing to watch out for with array declarations for dummy arguments is if you don't explicitly specify the lower bound, there is implicitly this business of the default lower bound being 1. You need to remember that in some circumstances. There is something called assumed shape, of which there is an example here, in which we pass in the arrays. Here there are 2, A and B. And in the declaration of these dummy arguments, we must specify a rank. So here we've specified these are dimension 2 rank, but we haven't specified explicitly the shape. This is taken from the actual arguments when the routine is called from the caller. So that's more general. You haven't hardwired in anywhere that these are a particular size or shape, but you must remember there is a bit of a gotcha in this issue with the lower bounds, which we'll come onto in an exercise a bit later. So if you want to explicitly check in the procedure, the subroutine or function, what the situation is, there are functions L bound and U bound, which will explicitly tell you what the lower bound was in the dummy argument. So for example, if we had a dummy argument declaration like so, we can find out what the lower bound in the first dimension is with a statement like that, and so on and so forth. So just to try and make this issue concrete, there's a small exercise here in section, where are we? Section 3.03, which is asking you to look at this issue. So let's have a look in section 3.03. I'm going to clear out the so there's a program 1 and module 1 are the things in question. So the module is defining a subroutine which takes two arrays of assumed shape. They're both rank 2. And it looks like the intention of the programmer was, I want to add or increment element-wise the elements of B with the values in A. So the exercise is to see where the potential pitfalls may be in that. I'll give you a couple of minutes to have a look at that one. Okay, so if we look at the program here, we can see we're going to use our module up here. Here's my implicit none, which I'm demanding always appears. So I have declared here two rank 2 arrays. However, they've got different shapes. So this A is going from 0 to I max plus 1, 0 to J max plus 1, where B is smaller, so it's a sort of subset of the larger array. So one is perfectly entitled to make some initializations which are initializing there 1 to I max, 1 to J max, and also there 1 to I max, 1 to J max for B. So if one was to try to call this array with this function subroutine we've defined with those two arguments so declared, one might be tempted to think the programmer wanted to add the corresponding array elements of these two arrays. But what is actually going to happen? Can anybody see? If you want to have a to examine this more closely, look at the module again. You can think about examining within the subroutine what are the lower bounds of the dummy arguments. Yeah, okay. So there's a bit of a what you need to watch out for here is, as I said, because we haven't specified anything, the code is going to assume by default the lower bound is 1, but that is not what is being assumed in the caller here, because you've passed in that call, you've passed in A, which has a lower bound of 0. So it is the shape that is passed, not the to get the assumed shape of the dummy argument. So that second call would probably be what the programmer was intending. Then you will add the elements of B to the corresponding elements in A. So that's something to watch out for with assumed shape. Okay, so one can do other interesting things. So in the same way as local variables, local scalar variables in a function or subroutine come into existence temporarily on the stack, you can do the same thing with temporary arrays. These are referred to in Fortran sometimes as automatic arrays. For example, if one wanted to swap the elements of two rank 1 arrays about, you need a temporary, so you can arrange for the appropriate storage. Here we've dimensioned this temporary integer array with the size of A, which can be computed at runtime. There's a slight assumption there that A and B have the same size. Notice also this is not strictly necessary. Again, one could imagine instead of these array assignments, you can just replace this with a loop and a scalar temporary, which means you don't have to have this potentially large temporary object coming into existence. Okay, so you may on occasion wish to have a dummy argument which is an allocatable array. That's fine. You just need to add the allocatable attribute in the attribute list in the declaration. So here we take some integers which are the bounds, and then we allocate the array in the subroutine. There's a couple of conditions needed for this to work. So if you have an allocatable dummy argument here, that must be matched in the caller by having an allocatable actual argument. And the intent here is relevant to both the allocation status and the data of the array. So an intent out allocatable array is one which is going to be allocated in the routine itself. There's a bit of another gotcha here if for intent out allocatable entities. So if that array is allocated on entry to this subroutine, it is automatically deallocated. If you think about it, that must be the case because you're going to allocate it again, but that can occasionally cause surprises, so there's one to watch out for most of the same sorts of arguments apply to functions. Okay, so one more thing which may be useful. We've seen yesterday some of the intrinsic functions I've been talking about, I've mentioned, have optional arguments. So we can write our own procedures with optional arguments. Again, we just need to add the optional attribute in the appropriate declaration. So here I have got one mandatory argument which always must be present, and I've got two optional arguments. So the deal with optional arguments is there must be a guard against the possibility that these arguments are not present in the invocation of the subroutine or function, and the guard in Fortran is this present intrinsic function. So that is saying if this argument is present, we can do something with its value. So that's the thing to watch out for with optional arguments. There's one exception to that. If you can pass through arguments which are optional to a second procedure in which the argument is also optional, so you can sort of chain these things together. You don't have to guard against. So if you want to use optional arguments in the caller, so if I take the example of this routine up here, where I've got one, first argument is mandatory, so that's positional argument, and I've just specified here I've got one optional argument which is not the first one in the definition, so I'm specifying this argument and I've missed out this flag argument. And you can do this by specifying the name of the dummy argument here and the actual argument in that way. So again, obviously the mandatory positional arguments must be in the right order, and optional arguments appear at most once. Okay, so here's a bit of an exercise. If you had to go yesterday at the tridiagonal matrix solution, you can use that, or you might like to just keep going and try that now. Don't have to do this exercise right now. There's also a template which has the solution basically in the current directory. So there's a couple of there's a bit of refactoring to do. So again, I'm going to get the message that I'm urging you to try and get all the functionality into module subroutines and functions, and there's a bit of practice on having some array arguments. Okay, so I'll allow perhaps 10 minutes for that. See how we're going. Yeah, some questions in the chat about compiler options. If you want the chapter and verse on compiler options, just look at the man page as usual, the first port of call. Because if you're on Archer, if you do man FTN, you get the FTN is actually the compiler wrapper, so you get the man page for the compiler wrapper, which may not be terribly useful. So if you want the man page of the Cray compiler itself, I think you have to do man Cray FTN, like so, and that will give you all the compiler options. If we do, let's go to GNU. Again, if you do man FDN, you'll get the same man page about the compiler wrapper, which is not terribly useful. But I think you can now the actual compiler behind this. Will be Fortran, which has some fairly standard options.